The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
Let them eat cake.
A real party crasher.
10W30, my favorite flavor.
A killer recipe. And a bathroom blockage.
I can do way better than that.
That's not to be sniffed at. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario.
All right, looking good. Bring it forward.
First up, the team recreates a disaster that, believe it or not, kills over 1,200 people every year.
May bring it down just a little bit.
Hey! Septic tanks like this one are common in rural areas. Allowing them to get clogged up can create a buildup of toxic gases. And in the right, or should I say wrong circumstances, this thing could turn into a gigantic boom bomb. Ugh. And that's what we're gonna recreate today.
Touchdown, baby.
All right, here you go, Francesca.
Oh, thank you.
They don't have time to wait for the dangerous buildup of gases or the blockages that could take years to happen naturally. So they've got to improvise a bit.
Lift with your knees.
Normally, septic tanks are buried underground, but they're building this one above ground so they can easily recreate the conditions that make a septic tank hazardous.
2 men carrying a toilet across the front yard. Totally normal.
So we've got ourselves a working septic system.
Septic systems use gravity to pipe human waste from the toilet inside the home to large holding tanks outside the home. Bacteria then breaks down the waste into toxic liquids and flammable gases, which are then meant to slowly release into the earth below.
How are we gonna make this a hazard?
Well, we can start by loading it up with the hazardous gases that get produced in a septic tank, like methane and hydrogen sulfide. That's a good start.
Aren't they just gonna leak out everywhere, though?
That's actually what happens in a normal septic tank.
Yeah, but if we block any of the escape routes, because having the gases in there isn't a problem, the problem arises when they can't get out. People put things into septic systems all the time they shouldn't. Coffee grinds, kitchen scraps.
Kitchen grease, which
Yeah.
is even worse.
Cat litter,
Cat litter, there you
Sanitary
go.
napkins,
Yeah,
diapers,
so many diapers.
watches,
cobs of corn.
uncooked hot dogs.
I think we got it. Well, what have we got here?
I bring you poo.
You bring me what?
Poo, manure.
And a tray of hot dogs, green beans, sausages, and diapers?
Yeah. Well, basically, your sausages and your green beans would be kitchen scraps. Your diapers, however, should not end up in your septic tank.
No. This is going to illustrate
Well, you
the
should-
human factor of people stuffing things down the toilet or the sink or what carburetor.
Start with a sausage link.
It's literally an explosive combination. Digested food will eventually decompose and release methane. Because the diapers don't break down as easily, they can clog the system, creating the dangerous buildup of gases. But before the hazard team releases the poo bomb, Francesca is about to show you how your dream kitchen can quickly become a nightmare.
I love the kitchen, but it's also one of the most dangerous places in the home. In fact, nearly half of all house fires in North America start on the kitchen stove. Every time you heat up a saucepan of oil, you are taking a big risk. Kitchen grease fires are so dangerous, they contribute to over $750 million in direct property damage every year. And the biggest risk comes when you accidentally drop some water in the hot oil. I've created this lever system. It will allow me to pull a string and release this ice into the hot oil from a safe distance. I also have some beeswax hands that I'm gonna use in place of my own. And most importantly, I brought in some friends. All right, everybody. We've got our canola oil boiling away. You can see the flames underneath. You can even see the smoke from the oil, which means it's above and beyond where it needs to be for us to have a grease fire. All right, guys, we're ready? Dropping the ice in 3, 2, 1, drop! Oh my God! Amazing!
It's okay.
That was incredible. The flames were up to the cover.
The ice drops to the bottom of the pot and instantly turns into steam. That steam displaces the oil out of the pot and into the gas flame. And there's your grease fire. We've seen how explosive canola oil can be, but is it the most explosive oil out there?
I understand what you did with the canola oil. That was sort of cool.
Yeah.
Sorta. I think motor oil is gonna be more fun.
Think it's crazy that someone would bring motor oil into the kitchen? Well, there are actual documented cases of this happening, with lethal results.
10W30, my favorite flavor.
Both oils are made up of hydrogen and carbon, but motor oil is a fossil fuel refined for a car engine and often includes other additives, such as detergents. It's a toxic mix not meant for human consumption.
Okay, everybody safe? Okay, on drop. Ready and drop.
Look at that! It's still going.
Yeah, no, it's going. Look at the wax running off that hand.
Pouring off of the hand. It's still going.
This is great. That was awesome.
If you look at the fires in slow motion, you can clearly see that the canola oil ignited much more violently than the motor oil.
Unlike the canola oil, motor oil contains around 25% additives, which allow it to withstand high pressures and minimize burning when it gets hot. So, Francesca and Brendan have shown just how explosive canola oil can be. But as firefighters will tell you, many people still panic and think that the best way to put out a grease fire is with water.
Oh my God!
All that water displaces the burning oil, spreading the fire.
That is exactly what you do not want to do when a grease fire is happening in your kitchen. That lit up the whole stove in a matter
That
of
was
seconds.
amazing. You can see all the tea towels are on fire. I think pretty much the only thing we can see in that room right now is smoke. I didn't think that was going to be that dangerous, but it is.
Two men carrying a toilet across the front yard. Totally normal.
The House Hazards team of experts has built a septic tank system to demonstrate why neglecting your tank or putting the wrong things in it can have fatal consequences.
A septic system is pretty simple. The sewage comes out of the toilet, into the pipe, and into the septic tank. In there, it starts to decompose from bacteria and enzymes into methane gas and hydrogen sulfide. Now, in a normal situation, these toxic gases wouldn't really be that dangerous unless you decided to stick your head inside the tank. But given the right circumstance, you could have a very explosive situation on your hands.
Dan?
Where did you get your poo, Brendan?
What kind of poo is this?
That's a family secret. Oh, maybe I should have put gloves on before I started.
It's too late now.
Good consistency, babe.
Look at that.
Perfect.
Is it possible that this poo is fizzing?
It's possible.
Yes.
It's making noises. It's pretty much the most disgusting thing I've seen in a long time.
Yeah.
So let's seal up the lid, pump it full of gas, and see what happens.
All right. Since we don't have a couple weeks to wait for methane to build up in our tank, we're gonna skip that step by pumping methane directly into the tank. All right, Brendan, you good?
Yep.
Here comes the gas.
And this is serious. Of the hundreds of people killed by septic tanks worldwide every year, many deaths are from exposure to the gases alone, which can overcome and asphyxiate a person in seconds.
Warning, poisonous gases do not enter.
Whenever you see it, you're just drawn to it.
A little bit.
All right, I think that's enough. I'm shutting off the gas.
Okay. We now have the makings of a gas bomb. I'm gonna feed it an ignition system, an electric match, down through this toilet, through the pipe, into the tank. Then I'm gonna clog the toilet with some diapers.
Now, realistically, we know that flushing a match or a cigarette would never actually make it into the septic tank. But conceivably, somebody could throw in maybe a cigar after they lift the lid of the tank. That's what our electric match is simulating. Ignition source.
Thank you.
Diapers.
Excellent. Let me get this down. Do you want to try flushing the toilet? See if that helps?
How clean is that toilet?
Not clean.
And by not clean, do you mean number 1 or number 2? Ew!
I didn't. All right. You want to run that back to the battery?
Yep.
Ready? All right, in 3, 2, 1.
The electric match instantly ignites the methane, oxidizing it and forcing it to explode outwards. This can happen if there's as little as 4% methane in the air.
That was pretty good.
That was okay.
Oh, come on, it's everywhere.
I can do way better than that.
Really? What are you gonna do?
Just hold on. Stay.
What does he mean he can do better than that?
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The House Hazards team is recreating everyday hazards that could turn your domestic retreat into a living hell. Even a child's birthday party holds hidden dangers.
Doesn't this party look like so much fun?
Helium is actually an inert gas, so there's no reaction taking place here. It's just less dense than oxygen. So our vocal cords are vibrating in a less dense environment, which creates a higher pitch.
Helium is fun and all, but this cylinder is pressurized and is really dangerous.
But, I mean, it's got a safety on it, so in itself, it's not entirely dangerous.
Well, that's the thing. When you transport it, you actually put on this safety so that there's no way that the top can be cleaved off.
Right.
But if ever it did, you basically got a 50-pound missile that's gonna fire through wherever it's going.
We're at a party, filling up balloons, somebody knocks it over, knocks this part off. You're saying it's gonna fly through a wall?
Exactly. You've got like 100, maybe 200 PSI of pressure in there, and it's gonna shoot it wherever it's pointing.
Are you thinking what I'm thinking?
I think this is a hazard that we need to test.
Every year, thousands of people are injured by pressurized canisters that have ruptured, either from falling over or being used improperly.
Are you sure you want to push this down the stairs? What if the top snaps off?
Go big or go home. That's exactly what we want. The hazard here is when this safety device, which takes longer to take off than you'd think, is off, and this tank topples over.
Oh, don't do that right now.
This thing's gonna snap off, and it's gonna send this flying, releasing all the pressure that's inside. In 3, 2, 1!
This is not as easy to break off as I thought it was going to be.
Now, we're gonna need something with a lot more power and a lot more bite. Just knocking down the canister didn't really work to make it rupture. This helium tank is so incredibly dangerous, I need to build some extra precautions before I can show you how hazardous it is. So I've got a helium guillotine back here that's gonna rip the head off. Then I've got these rails that I welded together, and that's what I'm gonna use to aim it.
The helium tank will be placed at the back of the rail system. At the top is a small explosive device, which can be detonated from the safety of the basement. When ignited, it will send force down, pushing a sharp guillotine, which can cut the head clean off the helium tank, releasing the trapped gases. The tank will follow the rails in a straight line. Otherwise, it could go in any direction and be a potential life-threatening hazard to the crew.
Okay, can we please get out of here?
Just give me 1 second.
To do what?
Hey, it's supposed to be a party.
You're gonna wanna come with us. Okay, you ready?
Yeah. In 3, 2, 1, let them eat cake. Yes! Win!
Why did that sound like it was right above us?
No more cake. It's gone.
Picked it up and shot it straight out.
Right through the window.
How far would you say that is?
It's got to be at least like 30, 40 pounds. It flew 60 feet or something like that.
Oh,
That's a lot of power. That is very dangerous.
I had no idea the force that was in that thing.
At 1,000 frames per second, you can see the tremendous force released through the small rupture. The helium was under such tremendous pressure that all it took was a slight opening and the gas expanded violently. Now, imagine this happening in a room full of kids. Definitely a hazard.
So you can see it went right through the window and then right through the railing.
I think it's fair to say, do not underestimate the power of a helium canister.
Oh my God.
What is that?
That is a giant mortar base.
The team has shown that a septic tank with even a small amount of gas buildup can have explosive results. But special effects expert Brendan wants to show the full impact of a methane explosion.
Really? Like bringing up mortars inside your septic tank?
You know, you guys don't have to hang around. If you guys want to go hang out in the bunker. Babies.
It'll be entertaining.
Entertaining or disturbing? Can I press the button?
Yes, yes, you can. You ready?
Yes, sir.
Are you ready on the trigger?
Oh, I'm so ready.
Okay. System is hot.
All right, in 3, 2, 1.
Even the most everyday domestic appliance can cause a whole lot of trouble in the home. The humble vacuum cleaner alone is responsible for up to 15,000 injuries every year. Most are due to electrocution. But as scientist Francesca is about to show in this extreme experiment, sometimes the hazard arises from human stupidity.
If you're gonna play with explosives, be careful not to spill them around the house. And if you do not use a vacuum to clean them up.
Think it's crazy that anybody would vacuum up gunpowder? Consider this. There are more than 80 million gun owners in North America. And this is the wrong way to clean up a spill. Gunpowder is a mixture of minerals that burn very easily. With a spinning electrical motor, all the particles inside a vacuum are generating static electricity. One spark is all it takes to ignite the gunpowder. That was a pretty big explosion for a small appliance. But nothing compared to the one special effects expert Brendan has planned. He wants to recreate the full destructive force of a septic tank explosion.
Just gonna wire this together, slap it on the car battery, the poo off the controller.
I know you're doing all the work, but can I press the button?
Yes, you can. Here. All right. Is everybody ready? You ready?
Yes, sir.
Are you ready on the trigger?
Oh, I'm so ready.
Okay. System is hot. It's up to you.
In 3, 2, 1.
Oh, gross.
A little extra. It was pretty good, do you think?
Man, that was big.
Imagine you'd been standing right there.
Can we go have a look?
Oh, you guys smell that? Oh, man. This is not okay. God.
Oh, God, man. Oh, it's like a swamp. And the toilet fell in, too.
It's not even funny.
Oh, it's a little ripe over here.
Yeah, no kidding.
Cleaning up? Not it.
No, not it! You clean up! This is what we learned today. Properly maintained septic tank is not necessarily hazardous. But with the right combination of circumstances, you can have a very dangerous situation.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
It's one of the most hazardous appliances in a home.
The team pushes a washing machine to its breaking point.
I think I peed my pants.
A catastrophe with household cleaners. And how your clothes dryer
How are we supposed to put this fire out?
can become too hot to handle. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The washing machine. Most of us have one at home. They may seem harmless, but they account for nearly $200 million in property damage every year in the U.S. The Hazard team wants to find out how this can happen.
All right, our washing machine here.
Yep.
How hazardous is it possibly?
I think it could be pretty hazardous. I mean, it's a motor, it's water, it's chemicals, it's electricity. I want to do the chemical approach. Fill the whole room full of bubbles. How do we do that?
Maybe putting the wrong soap in the washing machine.
Dish soap.
That's a mistake that somebody might actually make. Somebody, maybe your 14-year-old tries to do the laundry for the first time. He's like, hey, this'll work.
So why don't we start there?
All right.
Like liters and liters.
All right.
More.
Cross streams.
This is the point of no return, guys. There's nothing, no turning back.
This is this washing machine's last day. All right, let's turn this puppy on.
To the undiscerning eye, they may seem the same, but dish soap actually has a higher concentration of cleansing agents than laundry detergent, and this means a lot more bubbles.
It will get more exciting.
How long?
Well, I might try and subvert the float by adding water in through where the washing liquid. I'm not sure it will take any more water, but I want to try.
Washing machines have a mechanism called a float, which shuts off the water supply and keeps it from overflowing. But if this breaks, the water will just keep coming in, and you can easily have a flood. Exactly what the team is going to try to recreate.
How much are you gonna put in there? Just
As much as I can get in there. I've now got soap bubbles coming out.
that's what we want.
That is what we want. Well, the water's going somewhere. But still, this is not... I wanted bubbles.
Agreed.
The team just showed how the wrong kind of soap, coupled with a faulty overflow prevention mechanism, could cause some pretty serious water damage. But a washing machine can cause havoc in more ways than one.
I've got some ideas for where we can go from here that are better than bubbles.
That makes me nervous.
But before we find out what Brendan has in store for the washing machine, he's going to recreate a chemical combination that's responsible for dozens of 911 calls every year in the U.S.
Some of the most hazardous items in a home are located here, under the kitchen sink.
Everybody knows that kitchen cleaners can be poisonous, but in the hands of the wrong person and combined in the right way, they can be explosive.
Tinfoil. Water. Drain cleaner.
Many household cleaners contain compounds that, when mixed with aluminum, release a huge amount of hydrogen and heat. Put that in a sealed container, and you've got a mini hydrogen bomb.
Yes! That's what I wanted. Yeah.
Bottle bombs like this cause severe injuries. The blast from the explosion is strong enough to sever fingers, inflict third-degree burns, or cause permanent blindness. The hazard team has shown that the wrong kind of soap and broken valves inside your washer can combine for a real mess. Hazardous to your wallet, maybe, but not really to your health. So now, they're gonna ramp things up.
Under the right circumstances, this machine can be dangerous, and I want to show you how.
The primary safety mechanism on a washing machine? The door. In order to override this, Brendan is splicing two wires together to dupe the machine into thinking the door is closed when it's not. That way, the drum is open to whatever the team decides to introduce while it's running.
All right, we'll put it onto fast spin, and then... Perfect.
Front-loading washing machines use centrifugal force to pull water and soap through clothes. But if the weight inside the basin becomes unbalanced, the heaviest part starts pulling harder. And when that happens, you have a 300-pound motor spinning uncontrollably. And Brendan has his own way to show how foreign objects can cause an unbalanced load.
What are you doing?
Well, a little golfing today.
Didn't your mom tell you not to play sports in the house?
Yes, she did, and that is exactly why we're doing this now. Oh!
Golf balls may seem like a bizarre laundry item, but there have been documented cases of all kinds of things finding their way in there. From phones to cats, even the occasional small child.
No, no.
No?
This is what's happening.
That's not working. No, all the golf balls are in place and they're not moving.
There you go. Thank you. Thank you.
The centrifugal force is not really unbalanced. We're probably properly balancing it the more balls we put in.
I have planned for this. Hold on, I'll be back.
While Francesca and Dan wait to learn what Brendan has thought of next, they want to get the dirt on the nastiest places in your house. And they're starting with the toilet, which can contain up to 3.2 million bacteria per square inch. According to the World Toilet Organization, which really exists, the average person uses a toilet 2,500 times a year.
The toilet in this house has been used by a casting crew since we moved in.
In a typical toilet, once a person flushes, the flapper is lifted, releasing the water into the bowl, taking whatever is in there with it down the soil pipe. But not all of it. On a microscopic level, when the water is released, tiny droplets and airborne particles travel up to 8 feet outside the toilet, sending harmful bacteria all throughout your bathroom.
AKA the poop plume.
This may sound like an urban legend, but it's not. The bacteria most likely to float around the room is E. coli, which sickens millions worldwide every year.
Guys, hit the black lights!
All right, so how are we gonna test this? I've got some UV ink here that's basically gonna simulate liquid poop. We're gonna put it in the toilet, and when we flush it, wherever that poo would end up, we're gonna be able to see it with the UV ink.
And this UV light.
Sounds good. So we're gonna add the UV ink into the toilet.
All right.
Ready?
Oh, amazing. Let's get a little more in there. I would like to be as far away from this as possible. I say we ramp it up a little bit with this very scientific tool that I brought in to capture potential splashage.
All right.
A pot lid. This is gonna capture any splash, poo plume, what have you, that would have been expelled from the toilet. And lid goes on. I grant you the honor to flush away.
3, 2, 1.
That flush was a little weak. Let's try having a look at it.
Anything?
Not as dramatic as I thought it was gonna be.
I've got something that's way worse. You can stay in the bathroom if you want.
The plume depends on water pressure, which varies in every bathroom. Just because Francesca couldn't get this toilet to spray, she still knows that the bacteria found inside can be deadly.
Oh, God. This is a toilet seat. People put their butts on it dozens of times a day. You cannot get dirtier than that.
I don't like the idea of people putting their butts on that thing, but you know what? The kitchen sink has to be dirtier than that thing. You're putting kitchen scraps in there, washing uncooked meat in there. People even use that kitchen sink as their mop bucket. So everything that's on the floor everywhere just ends up right in there.
Fine. You know what? We're gonna test this with a bit of science. I have some Petri dishes.
All right.
Some swabs. You swab the sink, I'm gonna swab the toilet seat, and we'll let science determine which one's actually dirtier.
All right, sure. Put some gloves on.
Right. One dish for you, one
right.
for me. Happy swabbing. My swab is already dirty.
Yeah, mine is pretty rank as well. It's all brown and it's got a hair on it. In the bottom of the Petri dish, we've got something called agar. Now that's food for the bacteria. I'm basically putting all the bacteria I found in the sink into this thing, and they're gonna be happy and feasting, and they're gonna bloom. Whichever surface was dirtier is gonna have more bacteria, and therefore is gonna have a bigger culture on the agar.
So the hard work is over. Dan has swabbed the sink, I have swabbed the toilet seat. We've swabbed the agar, put the lids on, and we leave it for about 24 to 48 hours.
Yeah, we just gotta let them incubate. What do you wanna do?
Hang out?
Okay.
Ew.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program.
Didn't your mom tell you not to play sports in the house?
The team is testing the hazard level of an unbalanced load in a washing machine. Golf balls haven't done the trick, so they're taking this experiment to the next level.
That's not working. I need to introduce something else, like a brick.
Should we back up?
There we go.
Oh my God.
Seems to be compensating. They're just two little ones. Put a big one.
I think I peed my pants just a little bit. Okay, so that was horrifying.
When it stopped, you saw it jumped 6 inches into the air and leapt sideways. I think internally, it's done a lot more damage to itself than you think it has.
Say we didn't have a Brendan throwing bricks in. I mean, could this feasibly happen?
The unbalanced load, absolutely, and we didn't put that much weight compared to wet clothes. So if somebody had put, let's say, a full load to the brim and it was unbalanced, then you could actually end up with this kind of a rocking situation.
Think Dan's crazy? Well, the average brick weighs 5 pounds, about the same as a wet beach towel. Just a few large towels bunched to one side of the drum can create the same effect as the brick. After turning our washing machine into a 300-pound spinning catastrophe, it's time to check in on our dirty Petri dishes for an up-close look at the bacteria that sickens millions worldwide every year.
We're trying to determine which is worse when it comes to bacteria, the toilet or the kitchen sink.
The equipment we have to test this is a digital microscope that goes up to 150 times the human eye, as well as our Petri dishes with our bacteria cultures, and a trusty laptop so we can actually see the pictures. The key thing is that whichever surface was dirtier will have produced a larger bacteria culture. So we're gonna take our Petri dishes, look at them under the microscope, and whichever has more density or has covered more surface area will be the winner. Let's see the toilet seat first, maybe?
Yeah, have a look.
All right.
Prepare to be disgusted. Even without the microscope, you can see that there are funky things growing.
No, agreed. Looks like little hairs, like tendrils. Ugh.
That looks like Staphylococcus and maybe coliform bacteria. That can cause everything from vomiting to death in extreme cases.
What we see in there is definitely two different cultures, right? You've got these stringy little bacteria, and then you've got this cloudy one as well.
Okay, that's fair to say that that is.
It's pretty nasty, but look at our Petri dish. The toilet's Petri dish is only about half covered.
That is half too much, in terms of my opinion.
All right, well, let's have a look at our kitchen sink.
Oh my God. This sink swab is like 3/4 full. And I don't even need the microscope to see how dense that is.
No, agreed. And when we actually look in there, you can't actually see a single bacteria. It's just like this mound of absolute filth.
There's a cloud of bacteria from the sink.
There's barely, anyways, it's really hard to even see the difference between where the bacteria ends and where the agar begins.
Oh, man.
Granted, there's only one type of bacteria in there, but that's a heck of a whole lot.
I hate to say it, based on the science of it, the kitchen sink looks way dirtier.
That's the thing. People obsess about the toilet. They always think about what goes in it, and they think it's the dirtiest part of the house. But really, your kitchen sink sees a lot more bacteria go through it, and probably not as much cleaning.
The team has shown that an unbalanced load can be a real hazard. But don't forget that other appliance that sits in the laundry room, the clothes dryer. These domestic devices are responsible for 15,000 residential fires and 20 deaths every year in North America alone.
Dryers are one of the most hazardous appliances in a home. The hazard crew is bringing one out to the patio right now, and I'm gonna go make a dryer fire.
Clothes dryers use a thermostat to keep the inside air temperature below 120 degrees Celsius. If this fails, there's a real danger of fire.
Now, I've disabled 2 of the thermostats already, but the third one I took out of the housing, and I'm leaving it outside so that it doesn't know how hot it's actually getting. Now, lint is the main ingredient in a dryer fire. Now, I'm stuffing it back here onto the heating coils to simulate what would happen when a really, really dirty laundry room or an improperly cleaned lint trap would accumulate lint on the actual heating elements. I filled this dryer with as much lint as you can possibly fit in it. I'm gonna take the rest of the lint I have and put it inside the drum. Now, the lint up here plus the lint in there with my laundry equals big-ass fire. My father-in-law's baby blue suit. The final ingredient is fabric softener. Now, fabric softener itself is not a flammable liquid, but what it does do is make your clothes light and airy, which makes them more flammable. Here we go! Oh, we got smoke! See, the coils at the back lit right off the top because there was so much lint on it. I'm hoping that the actual drum catches on fire before the circuits or the electronics start to melt, because then that's just gonna fry the entire thing and the drum's gonna stop rolling. Oh, I like this! Oh, it's getting it! Come on, baby! And there we go. The circuit board just got fried, or maybe one of the wires melted, it shorted. All right, guys, let's get in there and make sure that it's out. If you look back here, we can see that the parts that were closest to where the fire was have been completely fried. All these wires have melted together. We probably ended up with a short, which is why our drum isn't moving anymore. You can easily see how a fire like the one I just started could spread through your home and turn it quickly to ash.
What's going on here, buddy?
Well, I was trying to make the dryer fire. It wasn't really as spectacular as I'd hoped.
You want a big fire?
You know what? I want a big fire.
Be right there.
While it seems like he's just trying to build a bigger fire than Dan's, Brendan is recreating a common laundry room hazard. The culprit? Dryer sheets. These sheets contain a small amount of petroleum to hold the softening agents. Over time, they can leave a residue inside the dryer, making it a fire hazard. In fact, these sheets are so flammable, wilderness survivalists use them to start fires.
Now we're gonna go blow it up. You ready?
Yes, sir.
Come on.
If you don't maintain your dryer, this is what could happen to you.
All right, ready?
Rock and roll.
All right, ready? 3, 2, 1.
Yes!
You like that?
That was perfect. See, that's a dryer fire. The fireball came out, blew the door open. Look, it's coming up the steps. Woo!
I say we put it in the pool.
Sounds good to me, man.
All right.
Got it?
Woohoo! All right. Into the pool.
That was a dryer fire. Now it's a pool dryer.
Next time you call me first.
Yeah.
Done.
Yeah.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
I'm ready to rock. Here we go.
The team pushes a stereo system to its auditory limits. A backyard party heats up.
Look at how high the flames are going.
You can feel the heat all the way over here. Oh.
And an air mattress that's guaranteed to keep you awake at night. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Nothing says home entertainment like a high-powered sound system. The more power, the better. But your stereo can be a danger to your home as well as your sanity. The Hazard team has an experiment to show you how. But it's not Brendan's questionable guitar skills under investigation today. It's the speakers themselves. A speaker works by sending electrical signals to a set of magnets, which push the speaker cone in and out, causing the air in front of the cone to vibrate. These vibrations create sound waves, which are measured in decibels.
The human ear will burst at 150 decibels. Now, this cone alone can go up to 120, and we've got about 24 of them here. So what Brendan's put together is a real sound weapon.
We could have fun with this.
Yeah, imagine if we pumped like 150 decibels into a window, for example.
This is a real hazard.
Sound is a form of energy that travels in waves. Normally, they're invisible when moving through the air. But by pouring a cornstarch mix into a speaker, it's possible to make this energy visible.
See, this is what it does. You see these guys? You see the creatures? There you go.
Wow!
That's what it does.
They look like little monsters. So the sound frequencies that are going on exist in everyday life, but we never get a chance to see them with the human eye. By creating this solid liquid mixture and allowing it to react to the frequencies, we can see what's going on a day-to-day basis with sound.
It's that same energy that the team wants to harness to find out how it can be a danger to your home. The target, a plate glass window. The Hazard team moves the speakers into place.
We're going to position them so that they're all facing the window, which will channel our sound waves directly to the pane of glass.
With the speakers set, the Hazard team is ready to test their theory.
That was sweaty work.
Get these wired.
While the team wires up the speakers inside, outside, Francesca and Dan want to test the danger levels of two common but highly flammable items found in nearly every backyard. Ah, the backyard party. Burgers, booze, and open flames. What could go wrong? As Dan and Francesca are about to find out, plenty. First up, the barbecue. Responsible for $29 million worth of property damage every year, it's a major hazard waiting to happen. And what fuels the barbecue? Propane.
Today, I'm gonna be cooking propane tanks instead of burgers.
Dan has an experiment to determine how hazardous these little canisters really are.
Turn this thing on high and light it up. You probably want to get back. Actually, guys, you guys want to get back too.
Well,
Guys,
hopefully
come on.
no one is
Back.
stupid enough to put propane canisters directly onto the grill. But accidents do happen. Anytime you've got flammable gas and an open flame, there's a potential for disaster. But Dan is conducting this over-the-top experiment to prove a point.
Barbecues can get up to 700 degrees Celsius. And if those tanks warm up that much, that gas is just going to want to blow out. Oh, I'm hearing something.
And I see flames.
Barbecue's on fire.
It's definitely not safe, but it's not an explosion either. Because propane is so explosive, these canisters have a safety install. They have pressure relief valves. When exposed to extreme heat, they slowly release the propane inside. In this case, The valves did their job, which is why there are only small bursts of flame instead of a violent explosion.
We were lucky that the pressure release blew out, but let's say that was a faulty pressure release. All of a sudden, you've got a rocket-propelled propane tank that's firing across your backyard.
But Francesca has something up her sleeve that could leave you with more than a hangover to deal with the next morning.
You probably want to get back. Actually, guys, you guys want to get back too.
Our engineer, Dan, has confirmed the obvious. Propane is flammable. But he also revealed how there are safeties put in place to prevent an explosion. Now, scientist Francesca is going to show what happens when a poolside cocktail party meets an open flame.
For those who like to entertain at home, a tiki bar makes perfect sense. Why travel all the way to Hawaii when you can bring Hawaii to your own backyard?
Makes sense to me. Lovely tiki bar you got here.
Do you like it? The only thing about a tiki bar, it's probably the most dangerous thing in a backyard.
What? What, because of the torches?
Because of the torches, but primarily because of something else. Take this 151 proof of rum.
High-proof alcohol. It's not just a hazard to your liver. More volatile than jet fuel, it can send your tiki party up in flames. Francesca is conducting an experiment to show just how flammable 151 proof rum is.
The fun begins.
When it's wet, gunpowder typically doesn't burn. But if the liquid has enough alcohol in it, it lights easily, despite being soaked.
So we're at a party and drinks are being poured. Oh no!
Rum spilling all over.
Rum is pouring everywhere.
Flammable liquids.
Not completely unfathomable. What else do you have at this tiki bar? Flame source for ambiance, but now it's close to our 151 proof, which goes up like that.
That's pretty hazardous. But I feel like that's a little bit of rum. What if you had a lot of rum?
Like a really good party going?
A really good party.
We can make that happen. It's a bit of a shame to be throwing this around.
Yeah, definitely
Watch out!
making me a little sad to see all this alcohol being spilled.
As alcohol heats up, it becomes easier to ignite, which makes this bright and sunny pool deck the perfect location for a tiki inferno.
Let's do it.
Ladder up. Yeah!
Look at how high the flames are going.
Oh, it's just so angry. That is burning way more intense than I thought it would.
I had no idea it would go up that fast.
Well, when you consider what, I mean, it's made of kindling, literally.
It's like 70% burned down right now. The only thing that's still burning are the wooden posts from the bar.
The alcohol vapors ignite first and start a chain reaction with everything else on the bar. The grass skirts, the napkins, the plastic cups all have higher ignition temperatures. Within seconds, a tiny, relatively cool flame has erupted into an 1,100-degree inferno, turning this tiki into Mount Krakatoa. When it comes to backyard hazards, alcohol has proven itself to be the winner. With the fiery luau finally extinguished, the team turns back to the destructive force of sound waves. The hazard team wants to know if a high-powered sound system can actually shatter a plate glass window. It's time for Brendan to rock the house.
Just in case the guys are right and it blows the glass out, we want to be in a safe place where we can watch all the amazing action without being in danger. Hey, Dan. Yeah? Come see the little bunker.
Nice.
Yeah.
Okay. Yeah, that works. Here he comes.
Oh my God.
All right, I'm ready.
You ready to rock?
I'm ready to rock.
Okay,
Yeah,
let's do
we're
it.
ready.
You ready?
We're
Put your ear
bunkered up.
protection on.
Okay.
All right. Reed, take me up. Turn it up.
Okay.
I'm ready to rock. Here we go.
It's shaking a little bit, but
It's not giving that like violent shaking that you need to break glass.
That's not working.
Yeah, I think I know what might be wrong, Brendan.
Yeah.
See, right now we're pumping a lot of pressure at the window, right? So we've got these huge amplitudes, we're really loud, a lot of decibels. But when you actually shatter glass, you need to hit the right frequency, and that's not something we're doing with that awful playing you're doing. I'll show you how, come on.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The breaker box. This unassuming gray panel keeps power running throughout your home. But it's also one of the most hazardous spots in your house. More than 28,000 electrical fires start in homes across North America every year. Many of them because of faulty wiring in a home's breaker box. Dan and Brendan are on a mission to show just how dangerous they can be.
There it is. All the power for the entire house runs through that panel.
This box is the gatekeeper for electricity into your home. Whenever there's a fault or too much current flowing through the house, it breaks that circuit and shuts it down. A malfunctioning breaker panel can bring fire and mayhem. Exactly what these two want to prove.
Over here, we've got some exposed wires. We've got a lot of dust in here. First, let's turn it off. Let's cut the grounds.
Okay.
Dan is removing the ground wires, which are safety lines that divert excess electricity into the earth. Without a ground, an overload has no choice but to travel through the nearest suitable conductor, which could be anyone standing near it. This may seem like sabotage for the fun of it, but Dan and Brendan are simulating the kind of dangerous conditions in thousands of homes across North America.
Completely ungrounded panel. We've got a lot of exposed wires. We can strip the wire so that there's arcing.
Okay.
Sounds good?
Yep.
Switch.
When electricity jumps through the air from an exposed wire, it produces a visible spark, an electrical arc that can start a full-blown house fire.
You know, we could pop a breaker and just jam something right in.
Actually, what I was thinking is, why don't we jam a fork into a breaker to complete a circuit?
Believe it or not, people actually stick metal objects like pennies and foil into their breaker boxes, thinking they can cheat a faulty circuit, often with electrifying and deadly results.
We've got an arc, we've got a short circuit. I think we've got ourselves,
An electrical fire?
Yeah.
Most breaker panels lie hidden in closets or basements where flammable objects can pile up without being noticed. Exactly the conditions they want to recreate. The only thing left to do is to turn the power back on.
All right.
All right.
Count me down, Dan.
3, 2, 1, go! Oh, man. Nice. That works. And now we got a nice electrical fire going. Perfect.
With no grounding and no way to stop the current, as soon as the power is switched on, an electrical spark ignites the material in the box, spreading to the walls and ceiling in seconds.
Oh, wow, look at that go.
The guys are on hand to quickly contain the situation, but in a real breaker box fire, the entire house could go up in flames before there's any time to identify where it started. The Hazard team has set up an experiment to show just how powerful sound can be by attempting to use stereo speakers to blow out the windows of the house. While Brendan's guitar playing may have rattled some nerves, the window held firm. But Dan has another more delicate plan. He's going to attempt to shatter glass using its own natural resonating frequency. First up, a crystal wine glass.
I'm gonna hit this glass, record the sound it makes, then play it back.
All right, you ready?
As the amplitudes overlap, the glass should vibrate violently and eventually break.
Okay, patch it through. Okay, I'm gonna send the exact same sound that the glass made into this speaker, and we're gonna see if it's gonna shatter. Ready?
I'm ready.
Good?
DJ Jan.
And kick it!
With the high-speed camera, you can see how the glass actually flexes back and forth at the same frequency as the recorded tone, nearly 450 cycles per second. Eventually, the flexing is so violent, the glass shatters.
So, let's apply that to the window.
See that on a big scale.
Yeah.
Next, Dan records the resonant frequency of the window and gets ready to play it back.
You ready?
I found the right frequency that'll blow that glass up, and I've patched it through to the keyboard. So when I push this key, we'll blow this thing. You ready?
We're ready.
Okay. 3, 2, 1.
Unlike the wine glass, the window glass is much thicker and has a much lower resonance.
Okay, that didn't work.
These speakers just aren't big enough for what the team has in mind. They want to blow the window out. For that, they'll need to bring out the big guns. But before Brendan reveals what he has in mind for the window, he has his own propane experiment he wants to conduct. Propane is a natural gas used to heat homes and fuel hot air balloons. Used properly, it's safe.
Why use my lungs when I can use a propane tank?
That's why the greatest hazard of all is human stupidity. Using propane to inflate an air mattress can turn a dip in the pool into the Hindenburg disaster. Brendan has inflated an air mattress with propane, and he's wired an ignition source to show just what happens when a static spark meets gas in something other than an approved container. Now, Brendan's determined to wreak the same havoc on the windows in the house. The team has successfully shattered a wine glass using sound frequency. But they're finding that busting window glass is much harder. They need a shock wave to break this glass, the pulse of energy created by the sonic boom of a jet. This kind of force has been known to blast out windows near air bases. Cue the big gun.
So this is an air cannon. It's a pressure vessel attached to a solenoid valve, which is attached to this big funnel here. What this does is we charge the pressure vessel up to 80 or 90 PSI. Then when I trigger the valve, it lets out all that air pressure at one shot. It will all travel up the funnel, straight into this sheet of glass. Boom.
An air cannon and a speaker cone both create air pressure, but with one crucial difference. While a speaker cone vibrates and pushes air outwards with waves of sound, Brendan's air cannon focuses that pressure and pushes it out in a single powerful blast, replicating the shock wave created by the sonic boom of a low-flying jet.
How loud is this gonna be?
It's gonna be loudish.
Ish.
We ready to go? Okay. 3, 2, 1, go!
gone right for my neck.
No kidding.
Oh, that was exciting. Shall we assess the damage?
Let's.
Oh.
All right.
Oh, wow. Look at that. It just completely blew apart. There's huge pieces everywhere.
The air cannon acts in the same way as a speaker, but exerting a pressure of 90 psi. The team has proved that sound can damage your home with frequency and pressure. Definitely a hazard.
That is one dangerous hazard.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
3, 2, 1.
Things light up under the sheets. A flesh-eating competition in the kitchen.
I just gotta get the bones in there.
And a party
Dance, dummies, dance!
hits the deck. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The balcony, a magnet for sunbathers and party people alike. But it's also a death trap waiting to fall. Deck collapses cause over 6,000 serious injuries a year. And the hazard team wants to know what it takes for one to come crashing down.
So you think we could put enough people out here to cause this deck to fail?
Yeah, if you want to maybe kill 20 of your closest friends.
All right, so we can't use people. Mannequins?
We've got mannequins.
There's no shortage of stand-ins to make a party, but they aren't nearly as heavy as the real thing.
Francesca!
His fly's undone. That's so embarrassing.
Most building codes set the weight limit for balconies at 100 pounds per square foot, meaning this balcony can hold about 2,000 pounds or 14 people safely.
I think it's the best to put as much weight as we can on the far side of the balcony.
Okay, sure. We'll load it up.
To compensate for mannequins, Dan and Francesca are going to add giant water barrels, which, when full, should be enough to overload the deck.
Turn on the pump! All right, here we go!
And as each barrel fills, Brendan is adding the equivalent of 2 extra people to the deck, inching the weight closer to the safety limit.
Nice aim, Brendan.
They're all full.
The weight of the water is now equal to the balcony's maximum capacity. But even with the additional weight of the mannequins, it's still hanging firm.
We really can't see any more stresses, or the balcony didn't even bow at all.
So what next?
While the team figures out another way to bring the balcony down, Brendan is about to compare 2 commonly found kitchen items that send more than 15,000 home chefs to emergency rooms every year. The meat grinder, a hazard that pounds flesh and bone through a series of crushing blades and tiny holes in the front.
Stick a digit in there, you lose a finger.
Pitted against it is drain cleaner, known by its chemical name as sodium hydroxide. Able to destroy anything organic in minutes, just think what it can do to human flesh.
So would it be more dangerous to stick your hand in the meat grinder or in a pile of sodium hydroxide? Instead of a human hand, we're gonna use this beautiful rack of ribs. All right, guys, come here. You have 10 minutes to pulverize a rack of ribs. Meat grinder, sodium hydroxide.
Okay.
You got 10 minutes. Go.
All right.
This meat grinder is gonna leave the sodium hydroxide in the dust. You can't compete with the brute force of these spinning blades that are just gonna pulverize whatever I put in there.
What Dan isn't thinking about is the amount of sodium hydroxide that I have. With this amount, it is going to turn those ribs into a meat milkshake.
Dan, are you ready?
Yes.
Francesca, are you ready?
I am so ready.
Okay then, 10 minutes. Go.
How you doing, Dan? You look a little stressed out over there.
Just gotta get the bones in there.
Just stirring in some chemicals. Sodium hydroxide is an extremely volatile chemical. When mixed with water too quickly, it can actually explode, which is why I'm gonna mix it very slowly.
Consumer meat grinder accidents are extremely rare. But when there is an injury, they're often so severe, they result in limb amputation.
Right. Think I am good to add raw meat. How's the muscle work going over there?
I just took a little break to let you catch up, but I'm almost done.
Oh, catch up. I'm done.
No, you're not. Look at your meat. Look at mine. Much more of my meat has been pulverized than yours, and I think I just broke the screw. Let's get a wrench in here. Brendan, can you get me a wrench, please, good sir?
As the clock ticks down, Dan and Brendan are trying to fix the meat grinder, while all Francesca has to do is wait as her drain cleaner attacks the ribs.
Hey, Brendan.
Yeah,
How much time is left?
2 minutes.
Huh. 2 minutes.
You have 10 minutes to pulverize a rack of ribs. Go.
The team is comparing which kitchen hazard is worse for your flesh, a meat grinder or drain cleaner.
Yeah.
With only a minute left, Dan's got his meat grinder back up and running, and Francesca's ribs are turning into a runny pink sludge.
I'm trying to think of the best way to describe this, and all that comes to mind is, ew, that is disgusting.
Sold in almost any hardware store, drain cleaner is so toxic that even a small splash can burn right through your flesh.
Okay, guys. 3, 2, 1, stop. All right, how did we do?
Everything has gone through the meat grinder.
That's actually really impressive. It's certainly ground up all the meat and the bones into Play-Doh. Let's see how you did. All right, this, well, you can, oh, geez. You can plainly see that the bones are still there. But the meat that's missing is not Play-Doh, it's gone. The meat is dissolved completely into, well, that's kind of fun. It's gross and powerful, though.
Okay, let me make something clear. Sodium hydroxide is incredibly dangerous. If I were to drink that meat smoothie, I'd be dead instantly.
So you actually think that you still won?
It's not I think that I won, I know that I won.
Completely less than 10 minutes. I had everything through the process, including the bones. You still have all your bones and some meat.
If we pull the bones out of there, the bones are stripped clean of any tissue, and here you have a pile of tissue.
The contest was getting rid of everything, including the bones, and you haven't done that.
The sodium hydroxide dissolved the meat, but it didn't dissolve the bones. So even though this was a close race, I'm gonna have to give it to Dan and his meat grinder.
Francesca's drain cleaner was impressive, liquefying the meat in minutes. But she's let down by the bones, which are still hanging on.
So even though this was a close race, I'm gonna have to give it to Dan and his meat grinder.
Meat grinder rules!
Back outside, the hazard team is considering flaws in the balcony's design that could lead to a fatal disaster. Most residential balconies use a cantilever design to support the people standing on them. This is the same design used in bridges, cranes, and even airplanes. But not all cantilevers are built the same.
Cantilever is basically a beam that's only supported at one end. Now, since just putting weight on our balcony didn't work, we're gonna test out some cantilever to see what it takes to break it.
This is one type of cantilever design. It's got this extra support wire out here, like a suspension bridge. This is a great design, very strong, but this isn't what we've got upstairs, so let's get rid of this.
This one here is a little bit better, because we've got our support far out, and our unsupported beam doesn't jet out too far, so it should probably hold a good amount of weight. But that's not what we want either, is it?
No, so let's get rid of it.
That looks about right.
Yeah.
On our balcony, the weight is being transferred back inside the house, making it extremely hard to break. But in a party scenario, there's also movement, creating a dynamic force that often surpasses the weight the balcony was designed to hold. To show this, Dan and Brendan are rigging up the exact amount of weight the poolside cantilever was designed to support, 150 pounds. Except this time, they plan to drop it from above, simulating what could happen upstairs if our mannequins started to move.
Let's do it.
Done. Hold on. Ready to go?
I'm ready to go.
I'm ready to go.
You ready to go?
On go?
On go. 3, 2, 1, go. I call that a success.
I call that a success. Weight plus movement equals broken deck.
Exactly.
So let's go break a deck.
Now that the Hazard team has learned how to move this party, Brendan is bringing out the big wheels.
You like that?
But this isn't just an exercise in demolition. Brendan's using the giant forklift for something more delicate, dancing.
We're gonna have to get this a lot higher if we're gonna get him to dance.
By hanging the mannequins from a wooden crossbar, puppet style, the crew can move them up and down like a wild party.
Are you guys all ready?
Yeah, they're all hooked up.
Dance, dummies, dance!
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Everybody knows that you should never take an electrical appliance into the bathtub with you. Nonetheless, consumer products like the hairdryer still kill an average of 75 North American adults every year. But what does it actually take for a dummy to get zapped?
Everybody's afraid of electrocuting themselves in the bathtub, right?
That is true.
In the morning, you've got a curling iron, a hairdryer going on in the bathroom, and you've got running water everywhere.
Yeah, you have a hairdryer and curling iron running at the same time?
I do.
It looks good.
Thank you. But we are legitimately afraid of electrocuting ourselves in the bathroom.
Absolutely.
So we're gonna see how realistic that fear really is. I've got a hairdryer, I'm gonna plug it in. We've got our mannequin, which rigged up with some twinkle lights in the bathtub. We're gonna throw this thing in and see what happens.
And that's the test. If the twinkle lights come on, there's enough electricity in the water to kill a human.
It's gonna light up like a Christmas tree.
Exactly. Plug in the hairdryer.
All right.
Hairdryer's working. Gonna throw it in, see what happens. Ready, in 3, 2, 1. Guys, can we get the lights back on? I kind of figured this would happen. We just basically blew the circuit.
So what you're saying is it's okay to blow dry my hair while I'm in the bath?
No, I'm not saying that it's okay to put an electrical appliance into your bathtub. What I am saying, however, is that there's a lot of things that need to go wrong in order for you to electrocute yourself.
Gotcha.
To keep people from being electrocuted, most new homes across Europe and North America have a built-in safety measure. Normally, electricity flows out of the outlet, through an appliance, and back into the outlet. Inside the circuit is a ground fault interrupter, or a GFI, that measures the current going in and out. If a human body enters the circuit, it draws power that doesn't go back into the outlet. If the difference in the current is as little as 5 milliamps, the GFI kicks in, shutting off the circuit, and you stay alive.
If you do want to see this thing electrocuted, I can show you how. All right, guys, it looks good. Let's get it down by a mailbox.
In order to demonstrate a real electrocution, Dan is bringing the experiment outside, where he has a power generator without a built-in GFI.
Perfect.
Just like in the bathroom, Dan's experiment must create a circuit, except this time, there'll be nothing to measure the current going in and out, allowing the electricity to travel from the hairdryer into the water, through the mannequin, and back to the generator without any interruption. Frying anyone stupid enough to be standing in the bathtub.
It's good to start filling up the tub.
Yes, madam.
The ladies are loving this.
All right, that looks like about enough water. Drinking water is nowhere near as conductive as salt water is. So for example, let's say our handsome mannequin decided to have one of these lovely, refreshing spa baths. So now we've got water that's about 100 times more conductive than normal drinking water. Next thing we need to do, set up our hairdryer with our generator.
And then drop it in.
And then drop it in.
Yeah, there you go.
All right, we're ready to rock and roll.
He should be terrified.
Are you scared? Say nothing if you want us to go. I think he wants us to go.
We're good to go.
All right, everybody, we're good to go.
Can I borrow that for just 1 second?
What?
Thanks.
All right. Stand back just a little. In 3, 2, 1.
They're lighting up! This is amazing! We did it!
This is really dangerous. This water right now is completely electrified, and our dummy, as you can see, is literally getting electrocuted. When we threw that hairdryer in, we're introducing electricity, and if you are the thing that completes that circuit, you're gonna get fried.
With the balcony carrying over 2,000 pounds of weight and the mannequins finally able to move, the hazard team is ready to test its strength once again.
Let's watch the show.
Dance, dummies, dance!
There's limbs flying.
He's gonna go first.
Don't jump!
Hey, Chris, give it all you got!
Now we're just breaking bones.
Oh my gosh, she lost her top.
All right, that's just indecent. All right, Chris. Well, that didn't work.
That was a bumping party, but it definitely didn't bring our deck down.
Under the combined force of the water barrels and dancing mannequins, the balcony finally starts to shake a little bit. But this isn't nearly enough to cause the serious damage needed for this party to get down.
So now what?
Last thing to do, poor maintenance, you weaken the structure.
Let's do that. I got the tools. Let's destroy this deck.
Things might not yet be hazardous outside, but Francesca has a party trick you never want to perform behind closed doors.
Here's one way to create fireworks in the bedroom. What could go wrong?
Francesca may seem crazy playing with fireworks in a bedroom, but unfortunately, this wasn't her idea. Every year in North America, 900 curious pyros push the limits of evolution by mixing fireworks with the indoors. Even storing fireworks indoors is a bad idea. After all, it's explosives inside your house.
Let's blow it up.
So for this experiment, Francesca's not going to just light up a few sparklers. She's making a full New Year's Eve display.
Okay, in 3, 2, 1. In 3, 2, 1. Wow. Get a little smoky.
More than just a fire hazard, fireworks also contain toxic chemicals, gases, and heavy metals, which, when combusted, are released into the air. Worst smoking section ever.
Holy. Fireworks in a bedroom. That is one way to heat up a bedroom.
last thing to do, poor maintenance, you weaken the structure.
Let's do that. I got the tools. Let's destroy this deck.
Adding weight didn't work, adding movement didn't work. So our final option is we're gonna compromise the integrity of the structure.
This may look like sheer vandalism, but by doing this, the team is recreating easily overlooked issues such as poor construction, insect damage, dry rot, and weathering, all of which could be a party crasher. The team has now done everything they can to compromise the balcony.
That's a terrifying sight.
And with the mannequins poised to do their part, Brendan is adding extra weight into the barrels in a last-ditch attempt to push this balcony into major hazard territory.
So Brendan is filling the front barrels. It's looking pretty safe right now. Do you see anything moving in the balcony?
One of the reasons we may not be seeing results is the break is going to occur at the seam where the cantilever meets the wall.
So what you're saying is there could be things happening in the house that we're not seeing from the outside.
Oh, God. Oh! Oh, you can just hear that rip apart.
Oh, that guy's being strangled.
His torso has been ripped apart. Oh, we can hear it. Do you hear those cracks? Oh, it wants to go. You can hear the cracks. It just wants to go so bad. Yeah!
Right down.
Boom!
You did it! Amazing!
Yeah! And there goes our patio set. Man, that thing took a punishment.
The end product is exactly what we wanted, right? Catastrophic failure. We added a little more weight, with those mannequins bouncing up and down. We distressed the beams. All those three elements came into play, and the deck went bye-bye. Well, this would be your 20 or 30 party guests had we actually been doing this.
Weight, movement, and wear and tear equals a huge hazard for patios and balconies.
Had this wood been old, aged, termite damage, with that weight, this is absolutely feasible to have happened.
So patios, house hazard, decks?
Absolutely.
Yeah, without a question.
Great.
Who's gonna clean this up?
Not me.
Yeah.
Not it.
Not it.
Got it.